other trig functions. These are not quite as useful for modeling situations as sine and cosine, but we do need to have a general idea of what the graphs look like. So the first one we're going to look at is tangent. This is what the graph of tangent looks like. You can see it's a lot different than sine and cosine. One of the biggest differences you're going to find with tangent is that its period is pi. So right here, you can see from 0 over to pi, we start to repeat again. So the period of tangent is pi. And the x-intercepts here on the graph, you can see, are at 0 pi, 2 pi. There'd be one at 3 pi, 4 pi, 5 pi, negative 2 pi. So we can write this like this, k times pi, where k is an integer. So every pi, basically, is what we're looking at. The y-intercept of this graph is at 0. And we have vertical asymptotes for this graph. So you can see right here, you've got over and over again these vertical lines where the graph gets closer and closer and closer and closer and closer, but it does not touch those lines. So these are our vertical asymptotes. You'll notice they're at negative pi over 2, positive pi over 2, 3 pi over 2, basically all of your pi over 2s. The way that we would have to write that here would be pi over 2 plus k pi, and we would still say k is an integer. So what that means is at pi over 2 we have an asymptote, and then if we go up pi we'll have another one, and if we go up pi again we'll have another one. So this is just intervals of pi that we're adding here. Don't worry too much about that. You can sort of just remember that this is negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on. Okay. So, the graph of cotangent looks very similar, except for it's sort of flipped upside down, which makes sense because tangent is sine over cosine, cotangent is cosine over sine. So the period of this graph is still pi. Your x-intercepts this time, they are at, this would be pi over 2 right here, and this would be 3 pi over 2. So they are at the same places you had asymptotes for the tangent function. So your x-intercepts would be at pi over 2 plus k times pi, where k is an integer. Y-intercepts, we have none for this because we have a asymptote at y equals 0, x equals 0. So our asymptotes here are at 0, pi, 2 pi, negative pi, so we can write k times pi, where k is an integer. Okay. So those are our graphs of tangent and cotangent. The biggest, I mean, obviously they look a lot different, but as far as equations go, the big difference we have to remember is the period for tangent and cotangent is only pi. Secant, these graphs look crazy, but what I want to do here for secant is I want to remind you that secant is 1 over cosine of x. And so if I graph cosine of x, I would have 1, 0, negative 1, 0, 1. You can see that cosine of x fits right between these functions. So a lot of times when I'm looking at the graphs of these and I have questions, I think about the cosine function, although the graph looks a lot different. We're not going to do all of this, but the period here is still 2 pi because it's based on cosine, so the period is still going to be 2 pi. Your y-intercept is at 1. And I think I'm going to skip this asymptotes, maximums, minimums for this. You can see those on the graph. You'll have Desmos on the actual exam, so I'm not going to worry too much about those right there. And the graph of cosecant, that would be 1 over sine. So if you think of graphing sine, sine has an x-intercept at 0, and then, I'm sorry, y. It does have an x and y-intercept, I guess, at 0. Just thinking y-intercept, though. And so if you graph sine, your graph, I guess I should do a dotted line, this is not part of the graph, fits nicely right there between the graph. The period of cosecant is also 2 pi because it is based on sine, and the period of sine is pi. The y-intercept, there is none here, and if you think about that, the sine of 0 is 0, so when you go cosecant, you get 1 over 0, which is undefined. That's why you have a vertical asymptote there. And I'm not going to worry about the locations of all of these right here. We're going to move on. Okay. So for each one of these, we're supposed to find the period of each function. And so for the period of each function, you are going to still look at that b value right here. However, when we're dealing with tangent, we are going to do pi divided by the number in front of our variable here. So in this case, there's nothing there. So the period of this function would just be pi. Cosecant, secant, those deal with sine and cosine, so you would say 2 pi over the b value here, which is 2, which would give you pi. For this one, you have a period of pi. For example 3, this is secant, which means you're going to start from 2 pi, and you've got x over 2 here, and x over 2 we could think of as 1/2 times x. So we've got to do 2 pi divided by 1/2, and that is going to be 2 pi times 2 over 1, which will give us 4 pi. So we have a period of 4 pi for number 3. Cotangent, remember, cotangent and tangent, our period for those is only pi. So we would take pi divided by, again, here we've got x over 5. So we're not going to do pi over 5 because x over 5 is the same as 1/5 times x. So we're going to do pi over 1/5. And so that would be pi times 5 over 1, dividing fractions easy as pi, flip that second and multiply, and that's just going to give us 5 pi there. So we have a period of 5 pi for that one. For example 5, I've got tangent again, so that means that I'm starting from pi, not 2 pi, when I figure my period. And so I've got pi times x, so I'm going to multiply and I'm going to divide by the number in front of that x, which is a pi, and pi divided by pi is just 1, so I would have a period of 1 for number 5. Okay. So the big thing to remember for tangent, cotangent, you have to use just pi divided by b, whereas for secant or cosecant, sine or cosine, you'll have 2 pi divided by b. Okay. So here's what some questions might look like that you might get here, which could be the equation of the graph below. So first of all, I've got cotangent and tangent. So I've got to remember that tangent is the graph that starts low and goes high. So this looks like a graph of tangent. It could look like a graph of cotangent if cotangent was flipped upside down, but cotangent does not have a negative in front of it. So I'm going to go ahead and mark out A and B. This is not the graph of cotangent. I do see that my midline here, that line that goes through the middle of the graph, looks to have been moved up. Looks like it will be about right here, which would be at 2, which means I should have a +2 on the end. However, that is not helpful because both of my answer choices have a +2 on the end. So the next thing I need to decide is if I have a phase shift or not. So if we flip back to our graph of tangent, notice that tangent's y-intercept is at 0, 0. So tangent's y-intercept is at 0, 0. This particular graph, its y-intercept is not at 0, 0, which means we had a phase shift. I can see B does not have a phase shift, so I would automatically know B's not the answer, C has to be. But if I'm checking to see what type of phase shift I have, it would be to the right, pi over 4, and so this would be pi over 4 right here. And so that point that would have been the y-intercept at 0 now is, or at the midline, I should say, is now moved to the right pi over 4. So C is in fact our answer. Now, if you get this on the final exam, just type in Desmos, see which one looks like it. But you may see some of these on the actual tests also where you don't have your calculator. Alright, for number 7, which of the following is the graph of 3 secant 2x plus 1? Now, I like to think that secant is 1 over cosine. Okay, so secant is 1 over cosine. So when I look at this, a lot of times I think about the graph that goes in between. So like, for example, here you've got a curve that goes in between, because I know a lot more about sine and cosine, and it just makes a little bit more sense. So I should have a midline at 1. So this looks like I have a midline right there at 1. You can see the midline on this one as well. Looks like it's at 1. Midline is 1 on this. And midline here would be 0. Right, so D is out. Okay. You also need an amplitude of 3. So amplitude of 3 means the distance from the midline to the highest point, or lowest point in this case, should be 3. So this has an amplitude of 3. B also has an amplitude of 3, but C only has an amplitude of 1. I'm not sure we actually call it an amplitude for secant, but we can think of it as the amplitude. So the last thing we have to think about is the period. So the period for this graph should be 2 pi over 2, which would just be pi. So this graph right here has a period of 2 pi. But this graph right here, if we think from one minimum point to the next minimum point, it only has a period of pi. So B would have to be the answer for this one. Okay. Alright, for number 8, we're supposed to write the equation of a tangent function that has a period of 4 pi and has been shifted down 5 units. So we'll have y equals tangent of something, and we've got to shift this down 5 units, so we'll put a minus 5 there. Now, this one does not have a phase shift, so I'm just going to put a bx right here. I know the period's supposed to be 4 pi, so I would take pi divided by b, and it would equal 4 pi. Now notice I used pi instead of 2 pi like we've done for a lot of the other problems. That's because we're dealing with tangent. The period for tangent is pi. So you've got to do pi divided by b. And so if I make this a fraction here, I can cross multiply, and I'll get 4 pi times b equals pi, and then divide by 4 pi. And the pi's will cancel, so I will get b is 1/4. So we would say y equals tangent of 1/4 x minus 5. You also might see this written like this: y equals tangent of x over 4 minus 5. Tangent can be stretched vertically, but I will generally not ask you to change that sort of amplitude number there for tangent, because it's not exactly an amplitude and it's difficult to see on the graph. I also could give you a phase shift, and phase shifts are still negative c over b for tangent, but probably won't see too many, quite as many of those, but maybe a few. We'll see one here in the next problem. So for number 9, it says write the equation of a cotangent function that has a period of pi over 2 and has been shifted to the left 4 units. So this one has been shifted to the left, so it does have a phase shift. So we'll have y equals cotangent of, right now I'm just going to put bx plus c. We do not have any vertical shifts, so I don't need a number out here on the end. And so I know that cotangent has a period of pi, and so pi over b should give me the period, and that should be pi over 2. So I could cross multiply without, if I want, but it's pretty obvious here that b has to equal 2. So I know I've got cotangent of 2x plus c. And the phase shift is the same for tangent as it is for the other problems. So negative c over 2 is going to give you your phase shift. And my phase shift is to be to the left 4 units. So left is negative, so I'm going to put negative 4. So if I cross multiply here, I get negative c equals negative 8, and that means c is going to equal positive 8. So my equation here is y equals cotangent of 2x plus 8. Okay, and that would be my equation here. So biggest thing you must remember, tangent has a period of pi. That's the biggest thing that you need to know. Secant, cosecant, sine, cosine, those all have periods of 2 pi, and generally everything you're going to find about the graph is going to work the same as sine and cosine. Tangent, everything works the same except for the period is going to be just pi.